In this lesson, we're going to have a look at the importance of rounding numbers to make it more relevant when you're actually using the numbers. So let's take a look at some of the important points in these notes. The first point is that you don't always need the exact answer when you're doing work, especially when you're doing practical work. For example, if you have a look here, you've got 61,348 people attending a football game. This approximates to 61,000 people, and that would be perfectly satisfactory to give people a guide to how many people were at the game. Now let's take a piece of timber that's 4 meters long, and we've got to cut it into 3 equal pieces. If we take 4 and divide it by 3, we get the answer 1.3 recurring meters long. Now, as they say here, it's impossible to actually cut the timber to that sort of accuracy. So we need to round. And the decision would be to round to say 1.33 meters or 1.333 meters, because that's actually still measurable. So perhaps there'll be some a little bit left over, but still very, very close, but it has to be rounded to be able to be cut accurately. What about families of 24 students in a class? A total of 55 children. Well, this would give an average of 2.2916 recurring children per family. Much better to approximate this answer, and there's your approximation, just to make the whole thing a little bit more sensible. So you can see the relevancy of actually rounding numbers. Now, most of us at this stage probably know how to round correctly, but let's just review some of the things that we need to do. Now look at 73. Is it close to 70 or is it closer to 80? And the answer here is that it's definitely, in this particular case, you would say closer to 70. So that if you took 73, you would say that it's approximately, and this is a symbol that can be used, approximately equal to 70 rather than 80. And we would say that this is rounded to the nearest 10. Having a bit of a delay with the pen here. There we go. 10. All right, let's look at B now. The question is 483 closer to 400 or 500? And I think you can see that it's definitely closer to 500. So we could say that 483 is approximately equal to 500. And once again, we'd say to the nearest, in this case, 100. So we'll say to the nearest 100. And the last question here says, is 3.5 closer to 3 or 4? Well, to tell you the truth, it's right in the middle. It's neither closer to 3 nor 4. So we call it by a convention. It's a decision that was made that we say that 3.5 will round up. And in this case, it goes to 4. So we say this would be rounded to the nearest whole number. All right, now a couple more points. It says to approximate numbers by rounding off, use these rules. And you need to underline these rules, even though most of you will know the rule already, still worth noting it. It says if the digit after the one being rounded off is less than 5, then we actually round down. And if the digit after the one being rounded off is 5 or more, we round up. So let's take some examples here and fix these up. Now I'm going to just push this up the page a little bit so we can see it. Down a bit. There we go, that should be the same as in your book now. Let's have a look at these ones, and we can do these fairly quickly. So it says round off 2,563.8 to the nearest first of all whole number. Okay, so let's have a look at these ones. To the nearest whole number would mean looking at the number 3. So let's write the number out here, 2563.8. So there's our unit, and if we look at 8, it's, as the rule says, 5 or more. It's obviously more than 5. So we would say then that it's approximately equal to 2564 to the nearest whole number. Now, we'll take the same number now, that's 2563.8, and round it to the nearest 10. So we look at it, I usually underline it, the point, that's the one in the tens position. And we look at the 3, it's less than 5, so we're going to round down. So we would say that it's approximately equal to 25, in this case 60. So the 63 is closer to 60, and we just leave it like that. Let's try 100 now. So we've got, I'll just put brackets around these so they separate from the number, the question itself. So we've got 2563.8. There's the 100 value, so to the nearest 100. We just look at the next digit, it's a 6. So we're going to say that this is going to round up, the 5 becomes a 6, and we use zeros as placeholders. So there's our number, 2,600 to the nearest 100. And finally, to the nearest 1,000. So we've got 2,563.8. There's the number there that we're looking at. So the second number is a 5. The convention says then that this becomes a 3. So there's the number that changes, and the rest become 0 values. So it's approximately equal to 3,000. All right, let's have a look at some more examples. When we round decimal numbers, the similar rule applies. So in this particular case, we've got 9.362, and to one decimal place, you've just got to make sure you identify the correct position. So this becomes 9 point. Now the number after is 6, so this becomes a 4, and we just leave it like that. We don't actually have to have place values, and we better put our approximate there because it's not equal, it's an approximate, or it's close to it. And for B, the same number is 9.362 to 2 decimal places. We look at that number there. The number after is 2, so we round down. It becomes 9.3, so the 62 part of it becomes 60, but we don't need the 0 at the end because we're only going to 2 decimal places. Now it's very important to look at HSC questions and see whether they ask you to round it off. If they do, you must do that because that's part of the question, and the examiners will expect to see those things there. The next point that I want to bring up before we finish this video is the concept of significant figures. Now this may be a little bit new to some of you, but let's have a look and see if we can work out what it is. I'll just get a highlighter here, and it says that the significant figures in a number are important or meaningful figures. So if they're significant, they are important, they are meaningful. There's a reason why we do it. So if you get a crowd of 61,348 people, and we approximate to this 61,000, we've actually done it to 2 figures of importance. There they are, 61 are the 2 figures that stay there. They are significant figures or important figures. Once again, it says it is impossible to cut a piece of timber into that particular length there. So, because you can't measure after the 4th figure, which is 1, 2, 3, 4, then the digits after that are meaningless because you actually can't measure them successfully in order to cut them. So let's have a look at what it means to actually round significant figures, and you'll need to watch this really carefully to make sure that you get it right. Here's the number, and I'll write it out again. A is 293,568. At the moment, there are 1, 2, 3, 4, 5, 6 significant figures. And it says rounded off to 1 significant figures. And what you do is you count from the left to the right. So count from the left to the right, and the first number that is not 0 is the first significant figure, and in this case it's 2. And I'll say that again, the first number as you go from left to right that is not 0 is the first significant figure. So in order to round this to 1 significant figure, the answer would be, well, you look at the 2, you still look at the number after it, in this case 9, and the 2 would become a 3. And all these other numbers need to be replaced with zeros as placeholders. So if I round this number here to 1 significant figure, the answer is 300,000. Let's look at how I do this now to 2 significant figures. That is the second significant figure. So I need 2 numbers that are not 0 in the answer. I look at the next number after 9, it's a 3. So this will stay as 29. And remember, all these other numbers have got to be replaced with a 0. 1, 2, 3, 4. Now you'll notice that the more significant figures I give, the more accurate the number, or the closer it is to the original number. This is a very significant one. It has 6 significant figures. This one has 1, it's quite rounded. This one has 2, a little bit more accurate. Let's try number 3. All right, 3 significant figures. Well, there's the third significant figure, and you'll notice the next number is a 5. So this will become a 4. So to 3 significant figures, we get 2, 9, 4, and these numbers now will become 0. So this is down now to 3 significant figures. 1, 2, 3 significant figures. Still the same number of places, but if it's not an actual number other than 0, all the other numbers become 0. They're basically placeholders. What happens when we've got a decimal? Well, the same rule applies, except that the first significant figure does not occur until the 7. So 0 and 0 are not significant because the rule is you read from left to right. The first number that is not a 0 is your first significant figure. So let's do this one now. To 1 significant figure, it would be 0.0. Now the question is, does the 7 change? The answer is yes, because the number after it is 5 or more. It's a 6, so this becomes 8. Now one thing you need to know with decimals is you can actually stop at that point, and you don't need to worry because the others are decimals. You don't need to have zeros. Now if you can just hold it there for a minute, I've just got to turn the power on for the computer because it's actually going flat. I won't be a moment. Okay, thank you. Back again. All right, let's have a look at the second one. Same number, but to 2 significant figures. So it's going to be 0.0. Now we've got 7 and 6, but the question is, because that's the second significant figure, do we change the 6? The answer is no, because the number after it is a 0. It's less than 5. So there it is to 2 significant figures. And finally, 3 significant figures. 0.0, first significant figure, second significant figure. Now this is very interesting. The third significant figure is a 0, and we don't change it because the number after it is a 4. So the 0 stays, and so here's a situation where we actually do write the 0, and the reason for it is we have been asked to give 3 significant figures, and in this case the 0 is a significant figure. So there's our solution. Have a go at some examples yourself just to practice the idea, but just remember the first significant figure is always the first I'll write it here for you. You should write this down. The first significant figure this is not working real well. The first significant figure is the first non-zero number reading from left to right. There we go. All right, have a try at some for practice.